Comparing and ordering decimals, let's talk about locating decimals on a number line. So how do we do it? Well, we start by determining the two numbers the decimal is between. So almost like boundary points. Let's locate the two whole numbers, the one that's below and the one that's above, to give ourselves kind of a breakdown. Then we're going to divide our number line into 10 equal parts, so tenths, if you will. We're going to mark the decimal. Where does it fit between those tenths? And then we will have our location. So here, as an example, if our whole numbers are 0 and 1, based off this number line, you can see how we have then 0.1, 0.2, 0.3, all the way up to 0.9. And this gives us a nice, easy, between the boundaries of 0 and 1, we've got some locators. And then we can decide where the number goes. So let's go ahead and do 0.7, locate 0.7 on a number line. So first, what are the two whole numbers that 0.7 lies between? Well, if you look at 0.7, the whole number in front of it is a 0. So the low end is going to be 0. The high end is one more than that. So it's going to be between 0 and 1. So we're going to take our number line, just like we saw before, between 0 and 1 and divide it into 10 equal parts. Then we'll put our decimal on. So if you think about, okay, from 0 to 1, we have our tenths marked. And 0.7, nice and easy, locates right there on the point, on the 0.7. So you can see how it is closer to 1 than it is to 0. Next, let's locate 3.25 on a number line. Again, where do we start? What are the two whole numbers that this is between? 3 and 4, because 3.25, if we round down, we get 3, round up, we get to 4. So those are the boundary points. Then we're going to divide that number line into 10 equal parts. And when you think about this, we're going into tenths, but 3.25 is halfway between 3.2 and 3.3. So just because we break it up into 10 equal parts does not mean that our point is going to lie on one of those parts. Those are giving us, a nice, easy way to break down that 3 to 4, that location of 1, into 10 equal parts. That way we have a better idea of where the number lies. If you just have a 3 and a 4 and you're like 3.25, it doesn't work as nicely. So we want to make sure that we have this spacing and gets a more accurate locating of that decimal on the number line. All right, you try one here. So hit pause, try this problem, then come back and check it out. So we're going to locate 0.64 and 0.46 on a number line. Then you're going to start by what are the boundary points, the two whole numbers on between. Now here we're doing two numbers, and luckily they're both between 0 and 1, because both of them start with a 0 point. So the low number is 0, the next one up is a 1. Let's make our number line into 10 equal parts and then put the decimals on. So if you think about this, 0.46, if we look at our tenths, 0.46 is about halfway between 0.4 and 0.5, might be just a touch closer to 0.5. 0.64 is halfway between 0.6 and 0.7, just a touch closer to 0.6. So you can see how they fall on the number line. You can also use locating numbers on a number line as a way to compare decimals. If we were comparing 0.64 and 0.46, whichever number is on the right is bigger. So we can see 0.64 is to the right of 0.46, and therefore 0.64 is greater than 0.46. Or 0.46 is less than 0.64. So you can use locating numbers on a locating decimals on a number line for a variety of reasons.